Hello everyone, welcome you all to the 16th session of exploratory data analysis. So in this session, we are going to study the importance of writing conclusions for different types of plots. And after that, we will study univariate, bivariate, and multivariate analysis. So let's start. Since we have learned a lot of concepts by now, I wanted to go over a couple of miscellaneous topics which are very important. So, for example, all the while I was just trying to explain you concepts. But if you look at the pair plots like this, so at the end of the plot, if you can see, I have wrote the observations, or you can say my conclusions. Again, observations could be misinterpreted as data points. Let's say this is my conclusions. So by looking at this plot, it's always important to write conclusions in simple words that everybody can understand. Please remember, as a data scientist or as a data analyst or even as a machine learning engineer, you do a lot of data analysis and you have to share your work with colleagues who may not be a data scientist, and hence it's always important to put your understanding, your conclusions, your interpretation in simple words so that your managers, your colleagues, and your non-technical peers for marketing, sales, all sorts of team can easily understand. Remember, as important as doing data analysis, equally important is communicating your results. So if you cannot communicate your results clearly in easily understandable terms, then your data analysis will never be actionable for the teams that you are doing this analysis for, or for the businesses that you want to improve. So I want to double down on this. In general, whenever there is a conclusion that you have understood, please write it in simple words with observations or conclusions just beneath it, because many people may not know what a pair plot is, but as soon as they read this, they know the conclusion that yes, petal length and petal width are important, and it's easy to separate setosa and not so easy to separate versicolor and virginica, because many people may not know what a pair plot is, but as soon as they read this, they know the conclusion that yes, petal length and petal width are important. And the moment you say, I can write simple if-else condition, wow, that's a terrific, right? I double emphasize this. Please write your conclusion of plots that you get in very simple words. Having said that, there is one problem that I often see, and one of the things that people do is people forget the objective, and they are solving the problem when they are doing the exploratory data analysis. Now, it's very important that you should summarize your plot. Why? Because summarizing the plots explain your findings and conclusions. And second thing is that you should do it. You should never forget your objective or problem in hand. And the third thing is that you should perform all your EDA aligned with your objective. So there might be 100 other findings in this data set, let's say this IDIS data set, which are not relevant to the problems we are solving. So always remember your objective. Our objective here is to classify our flowers into setosa, versicolor, and virginica, right? So all your data analysis should be aligned with your objective of trying to separate them. Here, let's say I could do 100 things. I could do many things which have got nothing to do. Let me give you an example. So here in this plot, while I was trying to explain you concepts like histogram, bin width, etc., and things like that, this was done on setosa flowers. Setosa flowers. Fine. So this analysis has got nothing to do with my objective of classifying. My objective here is classification. This is my objective. Fine. This is my objective. So it has got nothing to do with my objective. But I still drew it so as to explain you the concepts of what histogram is, what PDF is, what CDF is, and things like that. This is only for teaching purposes. But when you do it in the real world, you should perform your EDA, exploratory data analysis, without losing sight of your objective. I hope I made myself very clear, because if you do some random analysis, that's not going to help address the problem or solve the problem you are trying to solve. Having said that, let's define a few terms, because we have done a lot of analysis, but there are some terms associated with it. Let's see. Look at the first term. This is called univariate analysis. So when you are looking only at one variable, let's say my variable is petal length. Here in this case, I'm taking petal length as my variable. So if I'm looking only at petal length and I have plotted, let's say, histogram, box plots, Violin plots, etc., such an analysis where I'm taking one variable at a time and analyzing it, such a type of analysis is called univariate analysis. So all your PDFs, probability density function, all your CDF, cumulative density function, all your box plots, your Violin plots, etc., all of them are basically doing univariate analysis, right? Because we are taking one variable at a time and understanding what's happening there. Now the next concept is called bivariate analysis. So let me write here bivariate. So bivariate is nothing but your pair plots are actually bivariate. So basically pair plots are basically bivariate. Why the pair plots are bivariate analysis? Even your scatter plots are bivariate analysis, because I'm taking two variables at a time. Let's say I'm taking petal length and petal width. Fine. So in some of the plots, we saw petal length and petal width. So in paired plots, we saw all such combinations. So when you are looking at two variables and doing analysis, it's called bivariate analysis. Then the next thing is called multivariate analysis. Multivariate analysis. What is this? So multivariate analysis is when you are looking at more than two variables. Fine. For example, if you recall, let's say my 3D scatter plot, let me show you. So we saw this three-dimensional scatter plot, right? So this is an example of multivariate analysis. We have already discussed this 3D scatter plot. Of course, multivariate analysis is a very long and very large subject in itself, because all your machine learning is basically multivariate analysis. If I have to put it simply for you, because you have lots of variables. In our case, we have only, let's say, 4 variables: petal length, petal width, sepal length, and sepal width. So any model that you build, we are going to leverage all these 4 features. That is your sepal length. Let me write it here. Sepal length, sepal width, petal length, and petal width. So in the IRIS flower data set, we are only using these 4 variables, right? So what I'm trying to say you, all your machine learning is nothing but it's a glorified multivariate analysis. So if I have to put it in that way, it's basically your multivariate analysis, because in most of the machine learning cases, you will get to play with the variables, more than 2 types of variables. So that's all for today. Don't forget to subscribe and ring the bell icon. See you in the next session. Keep learning, keep smiling.